There's a breakfast cereal that's sold in Greece called Kappa Iota Chi, and some people have suggested that it had a subliminal effect on me when I was writing the name on tech the other day. Tony?
Don, could I put another sample up here?
Oh, okay. Oh, okay. We got a competition for Oh, gosh. Well, thanks very much. That was announced yesterday, huh? Thank you, Tony. Okay, so this is, some people thought that this had some relation to the logo for tech, so I had to bring it. Now, this is the Wizards class, and I also see some people in here who said they were going to come in anyway, even though they hadn't used tech that much. They thought by osmosis they would like to know what it would. Maybe they'd like to know what they would be able to understand in a year. So, however, I'm going to pitch my remarks at the people who are really experts, because after 4 years of experience with this and learning every few months, I think of another thing that opened my eyes, something I didn't believe I could do with tech, found a way to do it. I'm trying to communicate these things to you this week, and to the people who are going to be designing macro packages for others, and people who are going to be troubleshooting and possibly doing something with the implementation and so on. So we're going to go into the really arcane stuff, the really mysterious stuff. I plan in the definitive tech manual when it comes out to have a new appendix D for dirty tricks, and I'm going to explain some of those. Actually, probably this week I'll explain even some things that are dirtier than I would dare put in print. So so let's see what I have now. In order to get started, today I want to talk about the basic, at a detail level, exactly what tech looks like inside, and make sure that we understand the primitives, the tools that we're trying to bend to our uses. And so what I did was I made up a sample file that does nothing at all that anyone in his right mind would ever do, except that it does cause tech to print out a whole bunch of stuff indicating how tech functions. And so there's a handout that you can follow. Matter of fact, let's pass this around. Can we start this going around? So I made up this file called Goofy, which is the first page of the handout, and then the rest of the handout is the errors.temp file that you get from running Goofy. And the idea was to show you how that's in fine print. You'll notice the errors.temp file, but to show you exactly the kinds of information you can get tech to print for you if you want to do troubleshooting, as well as to get a good feeling as to exactly what tech is doing, because this printout shows really tech's thought processes, if you can dignify them by that name. It tells what tech's view of the situation is, and you want to know exactly what that is if you're going to advance to the extremes of what tech can do. Okay, so now this file does nothing useful, as I said. I start out just by putting in basic, but then I'm going to redefine a whole bunch of things, and I'm defining them in such a way that when the definitions are used, we'll be able to recognize them. So, for example, by saying tracing and turning almost everything on, I'll be getting a lot of output. Usually a user, of course, doesn't see all this output. I'm going to tell tech to print out a lot of stuff, everything except pauses. In other words, it doesn't pause on it when it hits a DDT or something like that. Now, so the widow line penalty I made 104, broken line penalty 105. So when you see later on tech inserting a penalty of 104, you know that this is because it thought there was a widow line there and things like that. Okay, break after a binary operation or relation, and so on. So we'll be, if these penalties occur, then we'll be able to know what they are. That's what these parameters actually are in TeX, and usually they're set to default values. I set the H size to 201, V size to 202, the power indent to 2.03, maths around 2.04. This is the space around the math formula. And then I made the top baseline 100 points. That's the baseline of the top thing on the page, and other glue is going to be inserted in order to make it come out to us that, if possible, the first thing on a page is going to have a baseline 100 points from the very top margin, and so I chose a number like 100, which would be easy to check for the arithmetic to see if it came out right. Max depth, I tried to make a characteristic decimal value here. This is the depth of the page at the bottom of the page. TeX tries to make the baseline at the top and the bottom both come out to be at the right place. So if you say that your V size is 10 inches, well then the bottom baseline is supposed to be 10 inches from the top margin, and this top baseline is supposed to be governed by this guy, if possible. Now, if actually there's a box that's so big that you can't do this, then TeX does the next best thing, and the max depth is one of the things that it. For example, at the very bottom baseline, if the bottom box has a depth more than this amount, then the bottom box is going to be shifted up so that its depth is actually redefined to be this. That's what that max depth is. And so baseline skip, I'm making 12 points, but I'm putting, so that you can recognize the baseline skip, we use the plus and minus part to be 301 and 401. The line skip will be 302 and 402. This way we'll be able to check whether or not, where our glue is coming from. A par skip is a skip after a paragraph. Display skips of different kinds. Top skip is, and bottom skips are for inserts if there were any. Tab skip is, in alignments, and par fill skip there. Is the space at the end of a paragraph that closes the last line of a paragraph. An X space skip is the space after a period or a question mark or something like that in the middle of a paragraph. Now I define top sep and bot sep. These are things that separate your inserts from the rest of the text on a page, and so we'll be able to recognize when they occur because it says T for top and B for bottom. And now comes the text that I'm going to be doing. Now there's homework this week, and your first homework assignment for tomorrow is to explain every number on the second page of the handout, second, third, fourth pages of the handout. You get so that you understand what all those numbers are, and I'll give you most of today's talk. I'm just going to be talking about give a basic idea of the understanding of those numbers, but actually you should look it over to the point where you understand everything, because this is exactly what this file tells TeX to do, and TeX is doing it faithfully, and you should be able to look at those and see why it does it. Otherwise, ask me to ask for the, ask tomorrow. But we've got to get the basics understood. Now, okay. Before I go into the rest of this file, though, I should review quickly the basics of boxes, and namely, namely TeX is a two-dimensional list processing language. It makes lists either in the horizontal direction or the vertical direction, and these lists can be the glue can be set in these lists and to make a box, and then that box can participate in another list, and so on. Now the rules are in the horizontal box. The horizontal box is made from taking the elements of a horizontal list, whatever these boxes are, and lining up the reference points all on the same place horizontally, and then if there might be glue between here, and the glue is computed by other means, but I'm trying to say what happens when you put boxes together into one other box, and then the resulting box. So it starts at its reference point is going to be the reference point of the very first box on the list, or if the list actually starts with glue, it will be it will be in the same line as that, but over here. So, suppose there were glue here. The first item were glue. So then the reference point for the whole box will be at the very left of the whole thing. And then the height of the whole box is going to be the maximum of the heights, and the depth will be the maximum of these depths. But never is negative or zero unless you've specified some fancy thing to get. It's not very easy to get a box of negative height. I think if you say V box to -1 point, you can get a box that's -1 point high, but it's about the only way. It's not very easy. Most of the time it comes out non-negative height. So if I had a null box that was only below the baseline, because I lowered it or something, then I think the height would still come out 0. Anyway, the final H box now has a height, a width, and a depth measured from the baseline. And it's not symmetrical. It only has these three things, not four. Reason is that although I considered at the early stage making the thing symmetrical, this would cause so much more memory and it would only help for setting Hebrew and things that I didn't bother to put it into the whole scheme. So there's only these three things: height, depth, and width. The reference point is always at the left-hand edge. Now that's a horizontal box, and when you start displaying a horizontal box, you know the coordinates of its reference point. Then you locate everything else from that. If it's glue, you move to the right. If it's by the proper amount, and then if it's a box, you know the reference point for where you are at that point, and you skip by the width of the box. Now the vertical lists are computed. You can say move left with a vertical list, and we get different reference points in these individual boxes that might be put into a vertical list. But when the whole thing is put into finally a box, V box, then the reference point is computed to be the reference point of the bottom one in the list. Unless the last thing in the list were glue, if the last thing in the list is glue, then it's after the glue, right below the glue. So the depth would always be 0 in the case where the last item in the list is not a box. The reference point, this thing that was moved left gets ignored. It doesn't stick. It'll stick out because we have only 3 dimensions. So the height of this thing will be the height all the way to the height of the top box or whatever glue is there, and the width will be the maximum width of the whole thing. And the depth will be the depth of the bottom box if it was a box. Otherwise, the depth is 0. Now, these basic rules for constructing boxes are used to do everything, so it's important that you got that in mind. And there's something else that isn't exactly clear, namely, how do you typeset this thing? Sometimes when you have negative glue in there, it's not clear whether the negative glue occurs, when the backspacing occurs, before or after a box. And here's the rule: you start out at the reference point, and you go up to the height of the. A V box is sort of reference point plus height is your standard starting place, and then you go through the V list, starting at reference point plus height and moving downwards. If somebody says, for example, V box to 10 point, and then you have some box here, box 0, followed by vertical stretching or shrinking. Compare that to V box to 10 point, vertical stretch or shrink, box 0. Now what's going to happen in these two cases? In both cases, we're going to get a box that's 10 points high. This is the height of the box. We don't control the depth of this. The height of the box is 10 points, and in the first case, you go up 10 points from the reference point of your final box, and then here comes box 0. With box 0, this is the top left corner of box 0. And then VSS adds enough stretching or shrinking to make the depth come out 0 and the height to be 10 points. On the other hand, if you put the VSS first and then box 0, I'm sorry, this is case A, and this is case B. In case B, you start here, you go up 10 points, and then you do as much stretching or shrinking as necessary, but the final box is going to be positioned here. The box 0 is going to have its reference point right at the same as the reference point of that V box, and it's going to be 10 points high, but the box 0 is going to be sitting there at the same position, and the depth of this box is going to be the same as the depth of box 0. So that's there's quite a difference there, and you have to understand the rule for expanding a V-box in terms of really relocate first the upper right corner and go down, upper left corner and go downwards when expanding a V-box. When expanding an H-box, we start at the reference point and go rightwards, and these are two slightly different things which should be understood if you're going to do anything tricky. Now, let me see. Yeah, question on that?
Well, the easiest way, if you wanted to have that particular box have its baseline sitting right on the reference point you drew, not its reference point, but its base. So the easiest way to have on the very bottom box the box with 0 height with its reference point to the left, and have that at the bottom of your V list, so it's nailed to the bottom reference point.
You say if I want to get a certain depth, if I want to get a certain depth, then I can say VSS and I can put a box with a certain depth here at the end of the list. Is that what you're saying? I don't quite, no? Oh. Can we have it on the screen? He'd like to see what I was drawing. If I put, in the second example, this is the last box in the list, okay?
Now suppose, actually I'm answering my question.
Okay, so the basics for constructing boxes I just told you then, horizontal and vertical. Now let's go and look at the things that can go inside the boxes, which are shown in this thing here. Now we started out goofy by a paragraph that has a hang indentation of 100 points. That means then that after the first line, this default is after one line. So the first line is going to be H size is 201 wide. The next line is going to be 101 points wide and shifted right 100 points. Now then it starts out with the word sill and then slanted acute accent LY italic correction. Okay, so silly comes in, and now this of course starts a paragraph, and so here's the beginning of a paragraph. By the way, after this silly paragraph gets going a while, in the middle of the paragraph there's a DDT, which is displaying what I'm about to show you. So the DDT, by putting DDT in and having this bit set in tracing, it means that at time of DDT I'm going to get a display of everything that TeX is doing. Well, this line here, SL expands into curve font N. That's because I'm also expanding macros here. I'm not really too interested in expanding the control sequences. So here we are. It's in horizontal. At this point, when the DDT occurred, TeX is in horizontal mode, and the space factor is 1. Space factor is used to control the space after. It's usually 1, but after a comma, it's 1 1/4. And this changes so that it leaves slightly more stretchability after a comma and things like this. The space factor is described. The manual, that's our current space factor. Now, the beginning of the paragraph started out with this thing, which was the paragraph indentation. A paragraph indentation is always a box with nothing in it, but it has a width. A width is equal to the amount of the indentation, which we described by par indent to be 2.03 points. That's why indentation is there. Okay, then we get the SIL in font A. So this means a character. This is after that box comes the character. These are all the things that are in the current horizontal list. And when I get to a V box here, the V box is in the list, but the dots underneath this say looking inside the V box. That's what's inside the V box. But this part as a unit is only one entry in the list because of these points in the first column. So if you look on the first column and everything that doesn't have a point in. When there's a point, that means that the things are grouped, okay? And similarly, when there's 2 points, that means that these two were a unit. So there's boxes inside of boxes in that case. And now we got to so the first four things in the list are the indentation, S, the I, and the L. Then comes a box, and this box represents the accented letter L. Okay, we switched to a slanted font and we accented the letter L, and this was the way TeX put the accent on it. The V box. Is, by the way, it gives the height and depth of the box. So the height of the box is 9.4, depth is 0, and this is the width. Whenever you have a box, you see the dimensions of it: height, depth, and width. So the first thing in the V box is an H box, this is the accent, the acute accent character number 16. This 16 is where the thing lives in the font for the accent. Shifted, this was shifted in order to center it. It shifted left a little bit. The accent was was made probably for a character that was a little wider than an L, so it had to shift this accent a little bit to the left. That shift is taken into account the amount of slanting, the fact that it has to raise this accent. The accent in the font is made as if it was to go over a letter X. It has to go over a letter L. It has to be moved up. The amount of moving was computed by setting the height of the V box, so that I figured out how high I wanted the accent to be, and I changed that height there. Then I put in enough glue to stretch or shrink to make it come out right. And finally, the last thing in the V box is this letter L, which is the accented letter. And since it's the last thing in the V box, the depth of this letter is what caused the depth of the V box to be 0, and the L itself is accented and appears on the baseline where it should. And the rest. So that's what an accented character looks like as far as TeX is concerned. In the horizontal list, it's a V box, and so we got an SIL V box and a Y in that list. Yeah. Question?
Why is the width of the whole box smaller than the width of the accent?
That's because it used the width of the letter L for that purpose. This V box was not computed by a V packaging, but this width was unilaterally set so that it would come out to be the width of the accented letter L. But the width of the accent, yeah, here it proves that the accent was wide. The accent was a wide box, but I had to shift it left in order to make it work. The width of the accent really doesn't affect the V box that you build for an accented letter. It's only used to compute how much you have to shift it to keep it centered. Now, the Y. Then comes the italic correction. Remember I asked for italic correction after that Y. So this H box with nothing in it, but a width of 8519 is the italic correction.
Does the italic correction go inside the braces of /SL?
No, it doesn't. Whenever italic correction comes along, TeX looks to see what the last thing in the V list was and looks at the italic correction of that character. If it's not a letter, it gives you an error message saying italic correction can only follow a letter. But if you had finished SL and done anything else, even changed the baseline skip or whatever, then you come to italic correction. It says, oh, I'm in horizontal mode. What was the last thing that I did in horizontal mode? Get the italic correction from that. The italic correction is something that belongs to the letter Y. This, when I say font N letter Y, this is a reference to TeX information about font N character number octal 162 or whatever it is, 161. And in that table, it'll tell what the height, depth, and italic correction and width are of every character. Question? Oh yeah, there's a microphone and you push the red button when you talk.
I was just wondering what the glue set of 0 on 2 of the lines. And
okay, yeah. Well, I'm glad you asked that, or not really. I don't understand why this glue set 0 came out. That means that it's epsilon. It's very small, but I don't know why it got very small. I think the italic correction must put a very tiny glue set that isn't going to make any difference in order to keep something from disappearing in the middle of math mode. But I really forget why this glue set 0 is there. Just forget it. The glue set is usually the amount that you multiply glue by. Now here, for example, when the glue set was -0, this means that it was negative, but positive, but not exactly 0. And when it gets multiplied by this, well, since it's negative, we're going to use the minus factors in the glue. So that whatever that is going to be multiplied by 10,000 here or 100,000 here, and going to give the true amount of space between those two. And you just can't see it. Precision isn't enough to see exactly what it is on that. This one, I don't understand why it has a glue set in there. Sorry. Maybe it should go out. I wondered about that too. The next glue here is the space between words. And so let's go back and see all that came out of typing this silly thing here. Now the next thing we type is a space, and then KER discretionary hyphen N real hyphen, and then I'm lowering a box. Well, let's see what I'm doing. I lower 20 points a box, an empty box. and then I did a top insert of something or other, and then a comma. So now, what's going in horizontal mode? Well, a space, letter K, letter E, letter R, a discretionary hyphen, an N, a real hyphen, and then a lowered box. That lower 20-point V box to 30-point is just a box that's empty, 30 points high, and it got lowered by 20 points. And then a top insert. This is a top insert in the middle of a paragraph. It means that this is something that has to go on the same page as this line of the paragraph. Top insert is if it appears in the middle of a paragraph, that means whatever page this line finally appears on, I want this insert to go on that same page, and that top insert of H box A is there. Then comes a comma and a carriage return. So that's the next thing in this H list. Let's see what happened. Tech did it. Okay. So first came the space between words. This comes out of the font. The font tells you what space to use between words. In computer modern that we get out of BASIC takes 1/3 of an M plus 1/6 of an M minus 1/9 of an M are the spacing that you usually get. Then comes KE. Notice it's sort of I guess it's justice that the word kern gets kerned inside, namely there's a little bit of space taken out between the K and the E to make them look just a little bit better, to put the E a little closer to the K. You really can't see that on the low resolution devices, but on the high resolution ones you can see it fine. And so this is a kern that got inserted when Tech saw K. It said, look and see what the next letter is. If it's an E or an O or a small number of things after a K that will cause kerning, then Tech will insert that into the middle of the list. This isn't going to interfere with the hyphenation algorithm. Question?
Is that the same method used for ligatures?
Ligature is exactly the same. Yeah, K could be followed by. But yeah, it looks ahead, and the same method for ligatures and kerning is used to make substitutions at that point. So this was brought together a little bit to make the word kern look a little more beautiful, except that we aren't ever going to look at this funny output. Next, here's the discretionary hyphen that was put in there. Notice it has a font associated with it, so that this discretionary is another thing that can appear in a list. Then, if it's a discretionary, that means that it's possible to break here. You have to pay a penalty for breaking. If you do break, use this character. And there's another discretionary coming in a minute that's not quite the same. Then comes the N and after the real hyphen. Following a real hyphen, I put a discretionary with 0 in here. Now, if you actually look at this, it says font, @ and the character 0. That's really 0. 0, because this is font 0, character 0. And that's a special case of discretionary which says don't insert any character. Just allow it as a legal break, and you pay a penalty for an explicit hyphen as an explicit hyphen penalty. The apostrophe is to make this octal. So this is an octal 0. In general, any character that isn't ASCII, ordinary ASCII printing character, like an N or a minus sign, will print with an octal code in front of it. So after a hyphen or a dash or something like that, you're going to get one of these discretionary zeros in there, and that's going to be the thing that causes a possible break to occur to the hyphenation routine. Otherwise, you get a discretionary thing with a particular font character code in mind. VBox is the next thing, and this VBox was 30 high and nothing wide. I don't see why the glue set printed. Maybe it computed something there, but it's epsilon anyway. But shifted 20 points. That's down. The amount of shift for something in a horizontal list means how much down to shift, and so that's why it was lowered in the source text. Arthur, you got the mic?
Yes. About the null discretionary hyphen, does that mean that there's a null in that character of the font?
No, it means that the discretionary doesn't look at it. There's no way to hyphenate with a font 0 character 0. In fact, you can. There's not too. The amount of discretionary things that you can do in the present version of TeX is rather limited. It has to be. It can only be a multiplication sign or something in character position octal 67, something wherever hyphen is in ASCII code, but it doesn't get put in but you can't very easily describe to TeX a macro that says insert a discretionary A here. Right now, that would have to be an extension. Top insert is the next thing that we did in that input, and the top insert. Remember that said something that's going to be inserted on this page. Now that appears right in the horizontal list, and the paragraph builder is going to take this top insert, and after the line is set, it's going to move the top insert out into the vertical list that the line appears. So this paragraph is going to be broken into lines, maybe 5 lines, maybe whatever line this one had a top insert in it. The top insert is going to be moved out of this box and brought down following it in the vertical list later on, so that the TeX will know to insert the thing on the same page as the line containing the insertion. Note inside that was just a box containing the letter A. Nothing interesting about that, except here's some glue after it. See what that is? That's the top skip glue that we put in there because we said the top skip was 0.30 plus 307 points, so that's a dead giveaway that this is the top skip glue. Here, top skip and bot skip are two things that are sort of anomalous in TeX language. Most of the time I've used Occam's razor and not put in things that were easy to put in with macros and so on, but at the time I put in top skip and bot skip, I thought that would handle a lot of things that later on I had to put other extensions in to TeX for better footnote handling and so on. That made it probably, it's not really it's a little frill to have in the language. Most of the time I didn't put in frills, but this was in there from the beginning. So you get this top skip automatically inserted every time if it's not 0. Then came a comma after the top insert, and then came the glue after the space after the comma. Now the space after a comma as I said, the space factor is a little different after a comma. Therefore, the glue wasn't 3.3 plus 1.6, but it was 3.3 plus 2.0. You see, it'll stretch a little bit more after a comma, shrink a little bit less after a comma because of the space factor was higher. You multiply this by the space factor and divide that by the space factor is what it is. Now, you can change the space factor to whatever you want by control sequence space factor. And then now, following this, what comes in our source file? So we finished this line. Weird as it is, we've already found out, though, in this line, all kinds of things that can exist in a horizontal list. Not just boxes, not just glue, also kerns, discretionaries, inserts. Okay. We haven't seen anything else, though, I guess. Kerns, discretionaries, inserts, and characters, of course. V boxes and H boxes have appeared in this list. Now, the next thing is math formula, $ B plus C equals D, $ period space. Okay, let's go and see what came from that. Well, now, I said that math surround was 2.04. So that means we're putting some space, 2.04 points of space, 2,400 space around every math formula. So here it is. It's given in terms of a kern of 2.04. This is different from glue because it's not allowed as a place to break a line. But there's something special about what happened if a line breaks at that glue, then this kern would actually go away, so that the formula would start left justified on the next line. Hyphenation 0 and hyphenation 1, which comes up later, this bracket's a math formula. Around every math formula we have 2 hyphenation things inserted in the list. This tells TeX not to use its normal hyphenation, not to break after glue, and not to try hyphenating any combinations of letters that you might find in that formula. It would look a little funny if your math you just happened to spell a word that got hyphenated between lines. So this says shut up hyphenation off, turn it back on again around the formula. So this will occur in a horizontal list, a hyphenation control note. Then the math formula itself was B plus C equals D. Well, what actually happened? Well, B got set in italic font G. Then came a glue and a plus sign. This glue is called the space around operators, and this is inserted before and after plus signs. So we got glue before and after that plus sign. And there's a penalty stuck before the second glue. This means it's possible to break after that plus sign if you have to, with paying a penalty of 106. That 106 is the thing that we said was the buy not break parameter. So 106 means that this was how we're specifying how much we want to break after penalty. If you don't want to break, after a binary operation. If you don't want to break after a binary operation, of course, you can set this parameter to 1,000, and 1,000 is a high enough penalty to inhibit breaking entirely. You control how desirable it is to break after binary operators. Like if I'm setting ragged right margins, I often set this to 1,000 and never break after, or maybe 900, something really bad, so that I will hardly ever break a formula after a plus sign. Now, breaking after a equal sign is another case, which is penalty for parameter 7, and that's another breaking after a relation. But similarly, this space was put before and after the relation, and then this is a penalty to break after the equal sign. It would be a legal place to break a line while making a paragraph. Typically not as much, though, as typically you charge more for breaking after an operation and not quite so much for breaking after an equal sign. And you can set these high if you like. B plus C equals D, the letters B, C, and D being in italics. The space around a relation is a thick space, and doesn't have any way to shrink. It can grow a little bit, but it can stretch, but it can't shrink. Space around a plus sign is allowed to shrink all the way down to 0, and to stretch just a little bit. Question in the back row?
Yes, how did TeX understand the difference between a binary operator and a relational operator? Does it really understand these formulas?
It's in there are 7 categories of things in a math formula: ordinary, binary, and the rules for classifying these things are spelled out in the manual. But everything is classified eventually in one of 7 ways, and like punctuation is one of the 7. Left delimiter, right delimiter. There are 7 things. When you type one of your codes, every code on the keyboard gets mapped into one of those 7 things by a big table in Appendix F. The first digit of that table tells you what kind of a thing it is. So an equal sign was classified as a relation in that table. Other control sequences will define what something is by saying, or you can say math bin or math op, and that tells TeX what type to treat the thing. If I wanted to treat this equal sign as a binary operator, I could say math bin bracket equals close bracket, and that would in fact I don't even need the brackets around it. You can just say math bin equals, and that will now be an equal sign treated as a binary operator. Nobody usually uses it as a binary operator, but it would use the penalty for binary operators, and it would also be converted to a unary if there wasn't anything in front of it, things like that. But the space around it, around a relation, is there's a table, a 7x7 table in the book that says what space to put when a symbol of one of the 7 classes is followed by a symbol of one of the others. And so here is an ordinary box C followed by a relation. This glue came from the table entry for ordinary followed by a relation. This penalty came from penalty following a relation. This glue came from relation followed by ordinary. If I had stopped the math formula with a dollar sign right after the equal sign, I'm not sure if the penalty comes out, but I know that the glue wouldn't come out. Okay. Next comes this kern, which is the space after the formula, and that actually is a legal break. Sorry, it's not a legal break. No, if it's followed by glue, that glue is a legal break, and the space of the kern is also thrown away.
When you say glue is a break, you mean in front of the glue or after?
Front of the glue is a break. The question was, when I say glue is a break, do I mean front of the glue or after the glue? And it means the whole glue disappears, but and is reset to 0 actually at the break. But the front of the glue is a legal break. The legal break is to break in a paragraph. We're going to talk a lot more about that tomorrow. But that's basically at glue and at penalties are the main things, if not all. Glue has to follow a box in order to be a legal break. A box or a character. Glue following glue is not a legal break. You can never break at the second, or glue following penalty is not a legal break. You'd break at the penalty, but not at the glue after it. Now, here's a new thing that gets in there, a rule. How did I get that rule? Let's go back to my source. Now, we finished the B plus C equals D period, except for one thing. The space after the space after the period, that's glue 5 plus 0.311 minus 0.411. That's because that's what I said was the X space skip. And X space skip is to be used after, for any time in space factor, I guess to be 3 or more, I think it is. This overrides what you would get from the font. Otherwise, the font tells you what space to use after a period. So that's how I got this particular glue. Next in my thing was a vertical rule, and I gave it a height of -3 points, and didn't mention its depth or width. Okay, now the rules for a vertical rule. You can now have a negative height, which means that the thing starts 0.3 of a point below the baseline. And then the depth of that rule is going to be to wherever the smallest enclosing box is. It'll extend down to that point, wherever the smallest enclosing box is. And the width of the rule for a vertical rule is the default here 4/10 of a point. So here's the way the rule is specified: a height of -3, a depth of star, which means extend up to the boundary, and a width of 0.4. Then came leaders. Now, leaders is another thing that can appear in a horizontal list. You can put leaders in the middle of a paragraph, and the leaders consist of something that goes in the leaders and then a glue afterwards. Leaders note should always be followed by glue as the next thing in the list. In this case, the thing in the leaders was a rule, a horizontal rule of the default height, and it'll extend as long as the leaders go. The glue here is 0 plus 100,000 points. What did I actually say to get that? I said leaders H rule H fill. So leaders, this is the thing that goes in and this is the glue that gets filled by the amount of leaders. And so that's another thing that you can stick in a paragraph. It's possible to break at the glue here, in which case the leaders would disappear entirely. If somebody wanted to make a funny looking paragraph where all the spaces in the paragraph were changed into leaders, they could do that, and then you'd have rules between all the words of the paragraph, but they disappear at the line breaks between one line and another. Send is another thing that can go in the middle of a horizontal list. Here I said send 0 help. And send is something that will send to a file. I haven't opened file 0, so this will actually go to my terminal. And the text help is going to be the thing that's going to be sent to the file or to the terminal. And that gets stuck in the file here. Send 0 help. That's something telling Tech that now this is going to stay in there with the horizontal list until the thing finally is output on some page or other. And then when the output routine is looking at this page and mostly typesetting letters, and it gets to a send instruction, that's when it will actually do the output to the file. Right now the send just gets stuck in there into the data structure and lives there for a while. Line break is another thing that a person can say in horizontal mode. That means force a break at the end of this line right here. And that comes in as an eject 0 in this printout. Eject 0. Eject 1 is when you say eject, and page break is eject 2. So there's 3 kinds of ejects that can be there. The line break, eject 0, is saying force a break at the end of this line right here. Eject 2 is a page break that says force a page break after this line, whatever. I'm not sure that I'm at the end of a line, but whatever line I'm in, break the page at that point. And then eject 1 combines both of those features. It says break the line here and also break the page here. David?
Can you have things like line break in between words? Do the line break attach themselves to the previous word? Or
the line break would occur right there, and this would be the end of the line. So this line would end with the send in this particular example. A line break should never follow a space unless you want the space to appear before the break. If you say space, and then line break, now this is actually a good idea if you want sometimes a person that instead of a paragraph end. Instead of par, you can say line break. I'm sorry, you can say like hfill, line break, and then this fills that line and goes on to the next line with no indentation. If you want an indentation, you could also give some kind of a box here. That would be indentation, H box to 20 points, nothing would be like. So this would be equivalent to par. It's almost identical to par as far as TeX is concerned. It would tie two paragraphs together, and both paragraphs would be set as a unit. So, for example, if you have hanging indentation that was supposed to stop after 7 lines, and the first paragraph was 5 lines long, then 2 lines of the second paragraph will have this hanging indentation, and then it'll go back. You can tie several paragraphs together by this means. The paragraph gets longer, and TeX might run out of memory if you tie all your paragraphs together, because it has to read the whole paragraph in a horizontal mode before it sets anything. But this way it can be done. Then, for example, if you say loose 1 around 3 paragraphs grouped this way, it will find the best way to add 1 line to the 3 paragraphs as a whole. So this is a way to put space before a line break. But if you want a line to come out, a word to come out flush right, then you give the word and then you say line break before you say space. Or you say unskip before that to remove the space. Arthur?
Suppose what you want to do is put a black slug right.
Are you using the mic?
Suppose what you want to do is put a black slug right justified against the right of a paragraph at the end.
Okay. That's something we'll talk about tomorrow. That's where you'd want to use par skip 0, par field 0. Okay. Now I want to get through as much as I can of this today before I get into paragraphing. I said send, help, eject 0, and then came what was next in my, after the line break I said H box please with question mark, space, and a page break, DDT. I'm getting near the end of this horizontal mode then. So here's an H box that bracketed the whole word PLEAS question mark, and that all fit in the H box. And the only thing that I can mention is that the following glue is the normal glue after letters, not the glue after a question mark. Normally a question mark would be like a period. It would end a sentence, but since it was in an H box, this space factor is only 1 after an H box. After an H box, space factor is reduced to 1. So this space here is not the same as you would get if I had left out PLEAS question mark out of the H box. I would have gotten more space after that question mark. Then came a space and a normal space and a page break. Okay, so that completes what the top level. It was saying horizontal space factor 1. That's the top level of what TeX is doing now. It's in horizontal mode, ready to accept something else for horizontal mode. Whatever you type after the DDT, still in horizontal mode, it's going to be added to this long, silly horizontal list that we've built. And I've shown you just about everything that can go in a horizontal list. I think everything, almost everything that can go in a horizontal list, not exactly everything. Kerns and the discretionaries and hyphenation controls, ejects, sends, all that stuff. When you make an extension to TeX, you can also get those things into a horizontal list, of course. And send is an example of an extension. It's treated as if it were an extension to TeX, and the send, all this routine of putting send in there is a typical example if you have to look at the code of how you would make an extension to TeX.
Is the effect on the original paragraph identical to the effect you'd get if one typed in what appears in the second page here?
The effect.
Well, I don't mean quite
Everything typed in.
but I mean all of these
macro calls are usable from the top level, like slash discretionary and slash current and so forth.
I don't have an easy way to get an arbitrary kern, for example. No, right now at the top level, not all of them. Most of them it is, but there are a couple of cases that are not completely general yet. Sorry. Now, then the next thing is vertical mode, outside of horizontal mode. After it finishes horizontal mode, what is it going to pop back to? And the answer is vertical mode. And there's a vertical list that's currently empty in vertical mode. And after vertical mode is the page building thing, and things that haven't yet been contributed to the current page. And so they might appear here, but there aren't any things pending in vertical mode yet. Not sure why. Usually the paragraph fill is there. No, well, let's see. I better check that out afterward. Now the current page is anything that's already been put on the current page, and there's nothing on that current page. So somehow, okay. So now, and nesting level 0 is how many levels of braces we're inside, and we're not inside any braces. Things that would undefined fonts and things like that, braces. So then Tech continues on and gets to the end of the paragraph. So after this DDT, where was I here? This DDT, then comes a displayed formula, and oh, this is complicated. It's an integral limit switch, so get the limits underneath the integral, sub r, and the square root of a over some garbage here, and then a DDT in the middle of the display, and then $2 signs. Then a blank line which finished the paragraph. Well, first when I got this $sign, I said start a display, which means flush out the paragraph as a whole that you've got up to now. So we flushed that out, and at that point we had a page break command, which says that you have to break a page at the end of this line. So that's going to cause something to be output. So that's why we got output. And this, when it says completed for page 1, is going to show me the exact box that now is sent out. So up to the line that contained that page break symbol. All right, now the page itself is a V box. The height of the V box is the V size. They had to set the glue rather high. It's going to stretch a lot because I forced it to break at the place where I said page break. The first thing you'll see in that V box on the page that got shipped out is this H box with an A in it. Anybody remember what that is? This is the top insert. So the top insert got put out first on the page because it was to be inserted at the top. The next thing is this T. That's the top sep. That's the separator between top insert and everything else. All right. The next thing comes the text on the page itself. Now here, this glue 74.9877. That's so complicated I won't expect you to figure it out. But that, remember, I said I wanted the top baseline on a page to be at 100 points from the top. Well, when there's an insert, it also takes it 100 points from the top after the inserts. I'm sorry about that, but that's the way it works. And the glue here is intended to add so that we get the top baseline 100 points from the top. However, you'll look at the next H box and it has a height of 10, and so actually where is the top baseline? It's not there. It's at 84.9 from the top instead. Well, the reason is that we also said max depth was equal to 4.9876543, and so this box, which has a depth of 20, had to be artificially regarded as if its depth was the max depth. And so what actually happened is this was treated as a box that was adjusted so that its depth its height to its depth was 30. And so if you add 30 to this, you get exactly 104.98. Which is the 100 plus the amount of depth. But I'm not going to say any more about it. Forget it if you don't want. That's a strange number there. Now, this is anyway, the first line of the paragraph, and so we get a lot of dots. All of this is the first line of the paragraph, and all of these, by the way, are the V box of the page that was sent to the output routine. Output routine, when it uses page, it gets this V box. All this is the paragraph, and the first line of the box is just the first line of the paragraph. Let's take a look where that line ended. Let's see, we got all this B plus C equals D, everything got on that same line, and even the leaders, and the send, and then the line break occurred right after the send, I believe, and so that's why we got a break right after the send. And so that line, from there to there, was just passed out as a line to be typeset. Next is a penalty 104. What does a penalty 104 come from? Well, that's what we specified was a widow line penalty. After the first line of a paragraph, we got to pay penalty of 104 for breaking a page at that point. But it didn't break there, and we got this glue on the next one. If you wonder why that line had a depth of 20, it's because of the V box that we lowered by 20 in the line. Now, the next thing is the glue between lines. When TeX puts things in vertical mode, it's got to calculate the right amount of space so that the baselines come separated by the amount we specified in the baseline skip. However, this previous line had a depth of 20, so it had a big thing in it. So there was no way to put the boxes together and maintain the stated baseline skip. So this is the line skip glue here. This is the amount that's used instead. When you can't achieve the baselines, then you put this much glue in between. Following that is the second line, and the second line of the paragraph was the please, and this is the par fill glue. So the end of the paragraph, what happened? We had a space here. This was a space before page break. Then came a penalty of infinity, essentially, and then the glue that was called par fill skip and that goes at the end of the last line of the paragraph. So that explains that one, and it outputs the page. While it's outputting the page, it's using basic format, so it centers the page number at the bottom of the page, and this bracket here 1 says it's printing page 1. Now, when it says bracket 1, then that means it's starting to output page 1. And when it prints the right bracket, it's finished output of page 1. The time, if you're watching your terminal, you want to see how much of the running time is going on between generating the text and actually sending it out to the output file. That's between this and the right bracket. Well, during that time, it discovered it was supposed to send the word help out to the terminal. So this is help here, then that comes before the right bracket. If you wanted to send a message to the operator, you can use send to send a message to the operator, but it might get a right bracket after it. If you don't like that, send also an empty thing, and that'll be another line on it. The right bracket will go to the next line. Okay, now, Jim?
I have a small question. I'm trying to figure out how exactly the page break interacts with the \DDT.
DDT is just a display of wherever you are at the moment.
It's saying to display everything, but it came right after the page break.
Yeah, but page break doesn't take effect until after the paragraph has been justified and broken into lines. Then the page break node gets moved out and appears as an eject node in the vertical list. And the vertical list, when the page builder comes along and sees an eject node, that's
so
when
it just saw page break, and then it read the rest of the paragraph.
Yeah.
And
because that page break means to put the paragraph in the optimum way, and then wherever that line is in the paragraph, then that becomes a place to break the page.
So had there been
Now the next thing we're out of time, but I have to tell you that this is something that we probably bypass from your homework problem, from the displayed math with incomplete NOAD to the end of this. Now the next DDT is in the middle of a displayed math, and we haven't completed the denominator of a formula. That's incomplete, means we can see the numerator but not the denominator. And inside a math formula, you have the 7 kinds of things: boxes, binary operators. Those are the only ones that probably show in this case. Op is another one, op. And then they have subscripts and superscripts attached to them. So a vertical arrow means this is part of the superscript of this box node, and a downward arrow is part of the subscript of something. So here's a box inside of a box with a superscript of that, but it's a nested construction, a little bit complicated. And this is what happens in math mode. Before you got to the end of the formula, TeX is just building a big tree structure of the formula, and it's in terms of these NOADs. And then after the end of the formula occurs, this tree structure is parsed into horizontal and vertical lists, and the formula occurs. So if you're really interested in math mode, you can see it before and after. This is when the tree structure is there. Then afterwards, when you see what actually gets sent to the page, these boxes and so on were built by the math formula. However, I didn't want to dwell on that in this. I'm just showing you that for those who are interested. Then at the end of this paragraph came a mark node, which you can only do in vertical mode, and then I did an alignment, which is the interesting part of your exercise for tomorrow. Figure out the meaning of the alignment, because the alignment, we're going to get a DET in the middle of the alignment, and you'll see what an alignment looks like before it's been finished. And out in the vertical list there is going to be this mark sitting there, which will affect the output routines and so on. Okay, so that's beginning, and we'll see you tomorrow. Huh?
We have our listeners have